Hey guys, I'm just going to go through the solutions for the sequences and series assignment. I'll go through some of the things that were quite good, perhaps some of the things that weren't what I would like to see, and we'll look at perhaps some of the things to watch out for when we do the mid-year exam. So we'll get cracking. So to start off with, for question one, it was pretty well done. Question one was good in finding the sequence. The next three terms, they were fine for you just to write. Some people did all the working for those, so substituting in, I guess, n equals 4, 5 and 6 and showing me all the working. You don't really need to do that for this, so it was fine to just show the rule, as long as you did expand and simplify to here, which was good, and then just list the next three terms. So you didn't need to do all the working here. Term 27, that was quite good, substituting in n equals 27 and getting your answer there. Part B, again, was quite well done. Same thing, you needed to work out the ratio, which most people did a great job of, and the first term. And once you had your rule again, you didn't need to provide the working out for those. It was fine just to list the next three terms. Okay. Find term 15, again, substitute in 15 in for n, get your answer. Try to keep it to 2 decimal places there, but other than that, it was quite well done. Now, this one was interesting, part 3, how many terms of this sequence needed to be added to obtain a total over 30,000. So those two words there, this part here, added and total, should be numbers suggesting that we want to find the sum of this particular sequence. Now, we can just say using the calculator that it was over, but we probably want to prove that it was the 18th term that got it over 30,000. So what should we be doing here? Well, what we want is to first put in our rule. Now, for this one, it was 15 times 1.5 to the power of, and minus 1. Let's go from 1 to 30, that's fine. And we also need to make sure our sum display is on, because we want to display the totals as we go. So anyway, we click OK, and what we're looking at is the second column here, because we're wanting to know the sum. So we scroll down here, and what we should see is that term 17, or S17, doesn't quite get it over the 30,000, but the sum of the first 18 do. So we actually want to show that. We want to show, well, the sum of the first 17 is under our 30,000, however, the sum of the first 18 is over that, therefore it is 18 terms. So for that one, that's what we were looking for there. Moving on to question 2, this was really well done. Most people did a great job of finding D and A, and then the rule, and then again, substituting in n equals 25. I'm going to be going through this pretty quickly, because my sort of idea is if I'm going too fast for you, you can sort of rewind or go back. Okay? So if you want to have a look at the working out, you can just pause or go back to re-see some of that. Part B was okay, yeah, mostly it was pretty good. We know that he's starting off in week 1 or term 1 at 86 kilograms, and term 8 or week 8 is term 8, and that's 81. The problem here was some people thought that this was geometric, so multiplying his weight by some sort of factor, but it says here he wants to lose the same amount of weight each week. That means he's losing the same amount of kilograms each week, which makes it arithmetic. So you're subtracting the same number each time. So it was actually arithmetic there, and if you did that, most people got to the right answer, which was he needs to lose 0.71 kilograms every week in order to get to his new weight. Okay, so looking for this indication of the same amount each week is what tells us that it's arithmetic. As for part C, this was really well done. Working out R, working out A, working out the term. Again, pause this if you need it, but overall a really good job with that. Okay? Over the page, find the 20th term of the sequence, and again, this was really good. You just need to substitute in n equals 20. The only thing I will say is that some people didn't recognise that it says to one decimal place, so you just needed to adjust your answer there. Moving on to part A of the next question. I'm just going to change the focus on this to see if I can make it a little clearer. Okay. So, part A of the next question, what feature of this graph indicates exponential growth? That means a curve, which we can kind of see here. What is it? Well, there's really two that I'd like to see. I know it says one, and probably in an exam one would be enough, but I want us to get into the habit of knowing both. So I actually made them a half mark each. So each term increases by a fixed ratio, and the second one, the difference between each term is increasing. So we can see here the difference between term 1 and 2, and then term 2 and 3, 3 and 4, 4 and 5, 5 and 6 is getting larger each time. For the sequence rule, again, really well done. Working out R, working out A, working out your rule. Very, very good for that. So well done. The last question, part C here, says, in what year will the population of rabbits first exceed 500? Comment on the reliability. So again, it doesn't actually tell us that we have to do it algebraically, so we can do it on our calculator. And again, when you do create your table, we want to show that term 14 does not get us there. It's under, but it's term 15 where it actually goes over. So some people wrote using the GC, it is term 15. And I get that, but what we really want to put in here is show that it's not 14, but it is 15, and then write down in the 15th year, okay? I know that's close up to 14, but it's in the 15th year, okay? The last part, which some people didn't answer, comment the reliability. Well, it's going to be unreliable due to extrapolation. That's pretty straightforward. We've been looking at that before, and we can see that our years only go up to 6, and we're ending up predicting up at about 15, so all the way along here, and so is obviously going to be unreliable. Moving on. Question 4. Part A, really well done. It says that it increases by 5%. Original price, 20,000. We were able to find term 6. Really good. Term rule, term 6. Well done. Very good. Rounded to 2 decimal places too, which was great. Part B was a tricky one and interesting, really interesting answer here. It then says, well, we know she starts at 20,000 and we know term 6 is 27,000, but in this case, we actually don't know what the percentage increase is. So we need to make that R. Now to figure that out, we first divide by 20,000 and we get to 1.35, then take the 5th root and we get 1.0618. Now what I think people did is saw the 2 decimal places here and rounded that down here. So did 1.06, so this part right here. The problem with that is it wants us to find the annual percentage to 2 decimal places. Now that's a bit different because to find this as a percentage increase, remember, just like this one, a 5% increase is 0.05. This is a 6.18% increase. So because the percentage needs to be to 2 decimal places, we actually need to include an extra few decimal places here in order to give us that for our answer. Okay, so remember, when it's asking this, this is the final answer. It's asking for 2 decimal places, so don't round it just yet. Overall, pretty good though. Question 5, the difference equation for this was very good. Work out the balance after 5 years. Well, to do this, we use our graphics. We go into recursive form. We put in the equation 1.052 Tn minus 4,200. Make sure you've got that on A0. So I might actually, no, I won't show you that. I'll just leave that there. But make sure after 5 years you figure that out. And again, predict when Sophie will have run out of money. Well, again, it's the same kind of thing. We want to show that after term 19, she hasn't run out, but term 20, that's when it becomes negative, so that's when it is when she's run out of money. So in the 20th year or something like that is what we want to say, because it doesn't quite get there after 19, but it's in the 20th year. So make sure, even if you are using a graphics calculator, you need to include some values here to justify your answer. Otherwise, anyone could just say using GC and then have a bit of a guess. But what we want to see is that you've worked out some values. And particularly when it's asking for when does it reach a certain point, we want you to show the one before to show that it hasn't quite reached it, and then the one where it actually does reach that value. So for this question, it's when it reaches 0, which is a negative value. Okay, so make sure you put that in there. We then get on to our coffee machine problem, which was a bit tricky, but most people did a pretty good job on this. Firstly, the two equations. I'm not going to go through those very much. It was very well done. Not too many mistakes there at all. Part B was really a bit of a typo. It said to do it algebraically. However, we can only really do this part's the cough pod algebraically. Cafe France, we need to use our graphics calculator. Okay, so for the first one, we can do it after they triple their initial sales, which means because cough pod's initial was 4,000, we now want to make it 12,000. Then we solve for n, which is 21 months. Okay, so just our equation, solve for n. For the next one, we want it to be 3,000 because its initial sales are 1,000, so triple multiplying by 3, we get 3,000 equals 1,000 times 1.2 to the power of n minus 1. Now again, we can't do this algebraically, so there's two ways you can do it. One way is to just put this equation here into your graphics calculator and generate the table. You'll notice that we do that quite a lot, and it's more than okay for you to do that. The other way of doing it is you can actually type this into main and click solve. So I'll show you how to do that here. So just get that out of the glare. If we go keyboard, solve, and we're just going to type it in. So 3,000 equals 1,000 times 1.2 to the power of, in brackets, x minus 1. And if I press equals, it'll actually come up with the answer there. So 7.025. And because it is more than 7, we need to say it's after 8 months that they will have achieved triple, because 7 whole months doesn't quite get us there. We need an extra 0.025, so it's after 8 months. Alternatively, you can write approximately 7 months, but probably we want to see after 8 months there. For part C, determine each company's total sales in the first 12 months. Well, again here, it doesn't actually say to do it algebraically, so you can just use the table of values. So by putting in the two equations in, generating the table of values, look for S12, that's your answer. And for the second one, S12, that's your answer. You can use the formulas, but if you don't have to use the formulas, if it doesn't say to use an equation or to do it algebraically, using the calculator is a good option. Finally, part D, that was the hard one here. Essentially, it says after how many months will the sales of Cafe France exceed Cough Pod? Well, the thing we need to actually recognise is what the graph looks like. If we were to plot both of these over time, you have one that's a straight line and the other that is a curve. This is Cough Pod, and this is Cafe France. Now, what this is kind of like a graph, I suppose, where this is time and this is sales. So initially, Cough Pod is higher than Cafe France, but at this point here, that is when Cafe France goes ahead. So there's two ways of looking at this. One way is to plot both sets of tables and then compare when one exceeds the other. That is fine. The alternative is to make the equations equal. You might remember from back in grade 10 when you wanted to find the intersection between two graphs. It was when they were equal to one another. So 400n plus 3,600, that was the Cough Pod equation, is equal to 1,000 times 1.2 to the power of n minus 1. That was the Cafe France equation. And again, we use the solve tool in main, and it will tell you that n equals 12.9 months, which means that it is after 13 months. Now, I've written an alternative is to compare the table of values. I'll briefly show you how to do that here. So we are in explicit form, and one of them is 410 plus 3,600. The other is 1,000 times 1.2 power of x plus 1. And if I do both of these at the same time, and then I'm going to get rid of the sum display, just because when I do my table of values, I used x. And what I can do is I now have the sales after each month. And what I can do is I can see blue is always ahead of red, but then I can find the point, where it takes over, which is here. You can see blue's still ahead after 12 months, but after 13, then red is ahead. So that's when it would take over and exceed those values. So that's another way of doing it, by sort of plotting both at once. Okay, so another option that you can choose for that. Okay. Question 7, for this one here, Park Ranger, there's 1,000 at the start of the year, and then 1,250 at the start of 2015. If it's a linear increase, find the rule. Well, D would be 250. Here's our rule, and yep, check that works. All right. So find at the start of 2019. Well, that would be T6, 2,250. That's our answer. The next one is, well, what if it was exponential instead? So we need to work out an R value, A, find our rule, and then, again, term 6 would be 3,052. This is a common exam problem where they give you the start of a sequence and they say, well, what if it was linear or what if it was geometric, and to find both of those. So that's another type of problems that you will see quite often. A hint or key here is to work out that 2019 is term 6, 2014 is term 1, so then 15 is 2, 16 is 3, 17 is 4, 18 is 5, and then 2019, that must be term 6. It then says, due to culling, they have a difference equation, which looks like this. Now, it says it's in the form RTN plus D, and T naught is 2,500. Well, we know from this question here, it says, using the R value from the previous question, where R is the ratio from part B, so that's 1.25. D is the number of kangaroos culled. We don't know what it is, so we're just going to leave it as D there. So that's our answer for part A, or part C. Sorry about that. So part 1, we just needed to leave it at D. For part D though, what we have here is it says determine the number of kangaroos, as mentioned in part C, that have to be culled so that the population stays at the steady state of 2,500. So the key here is to recognise that Tn and Tn plus 1 are going to be the same value, 2,500, and we're solving for this value for D. So we substitute those into our original equation here, so 2,500 here and here, and we end up solving for D, which is 625 kangaroos that can be culled. Question 8, the last one, we start off here with a difference equation again, and we're given values for the number of trout, which increased by 35%, so 1.35, and it says 200 will be caught, so minus 200 here. Initially it says there are 600, so we'll put that as T naught. The reason we're using T naught as opposed to T1 is because it's saying initially, so that's after 0 years, okay? So we then need to plot this using our calculator, and in doing so we need to make sure that we include the time in years and the number of trout on this axis and try and sketch it as accurately as we can. There are a few people that just didn't provide enough information or detail on this particular part of the question. Part C, it then says, well, as it turns out, they actually catch 300 a year, so we need to just change our difference equation slightly, and it asks us to discuss what happens to the trout population. Now, we don't necessarily need to do this the way I did. You could say using GC what happens, but essentially after 4 years there's only 3 left. After 5 years, obviously it says there's negative, but we know that that's not possible, but essentially there are 0 left. So we would say the population is depleted after either approximately 4 years, you could say, or in the 5th year. So you could say that there are no trout left after approximately 4 years, or probably what is better is to say is in the 5th year there will be none left. Finally, we have another steady state question where again it says they want a steady state of 600, but now we're looking for the number that people can catch if that breeding number stays the same, and they do want a steady state. So they don't necessarily need the trout to increase, but they don't want it to decrease either. So again, Tn equals Tn plus 1, which is 600. We then sub both of those into our difference equation and rearrange and solve for D, and then we can work out that 210 trout can be caught each year for it to be in steady state. So that was it. That was the assignment debrief. Overall, it was a pretty good effort by most people. I will say to make sure you check over some of these things. A lot of these types of problems will be in the mid-year exam. So make sure if there's anything you're not sure of, look back through this video, rewind, pause, whatever. And if you have any more questions, please let me know. Thanks, guys.